All right, I'd like to welcome everybody here to the Super Circuit Networking 101 webinar. If you'll just give me just a couple of seconds, we'll let everybody join and we'll get started momentarily. All right, thank everybody for joining us. We're about to get started right now. Again, this is the Super Circuits Networking 101 webinar. Before we get started, I wanted to cover a few things. As of right now, I have everybody on mute. If you have a question during the presentation, on your screen you'll see this hand. Please select it, and it'll notify me that you are wanting to ask a question. I'll pause my presentation, unmute you, allow you to ask your question, answer it, and then continue on to the presentation. I would like to ask that everyone please try to hold your questions until the end of the presentation. Our presentation should last between 30 and 40 minutes. Afterwards, I'll be doing Q&A. So if you could just write down your questions, it would help us move through the presentation. The goal of the training and our roadmap, just for everyone to know, is the goal of this training is an education-only webinar. It is to help you have an understanding of IP. What we've realized and what we think is happening is a lot of our dealers are analog experts, but they don't really know that much about IP. Hopefully, when I'm finished with this webinar, you'll be educated enough to talk to your customers and hopefully allow you to sell more IP products. Every month I'm going to be hosting a webinar. We're going to alternate between like a non-sales education-only webinar like today, and then we're going to follow it up the next month with a gear and how that information from the previous training applies to our gear. Next month we're going to be doing our embedded DVR and our IP NVRs along with how our DNS service applies to them. At the end of this, we want to be able to give you the knowledge and the tools to land any job that comes your way. Okay, let's get started. What we're going to cover now is basic IP 101. We're going to start out with what's a network. Everybody hears the word network thrown around pretty loosely, but a lot of people don't really know what one is. A network is two or more devices that are connected together that share hardware and software. They usually share the same topology and protocols. Below is a good representation of an IP camera network. You'll see that our DHCP IP cameras are cabled into a switch. It also shows the video network recorder. From there, you'll see the client, workstation, and router, everything pulled together. On this network, you'll see that it goes into the internet, and it'll show the smartphones connecting to it as well as a remote workstation. Next, we're going to talk about local area networks. A local area network is called a LAN. Everybody says, well, what do you have on your LAN? Are you going to create your own LAN? And a lot of people, especially dealers that are expert in analog but haven't really put in IP systems, they don't really know what one is. So I really wanted to kind of educate you on what a LAN is. A LAN is a local area network. It is called a LAN because of the way it's set up. LAN technologies include, or LAN topologies include bus, star, and ring. Most everybody is going to be set up on a star topology. If you look below, I've got a star topology set up on a LAN. It's several computers set up that way. What I would like to really emphasize here is that 95% of every topology on a LAN is a star topology. You'll want to use a star topology because if one computer or device drops off, you will not lose your network. Next, I'm going to cover wide area networks. What's cool about a wide area network is it's called a WAN. What it allows you to do is, it allows you to connect two remote locations via a leased line and treat it like one big LAN or a WAN. For my map here, I'm going to give you a good example. Imagine if you have your business in Dallas, and then it's set up with its own LAN, and then you have your business in Houston, and it's set up with its own LAN. Well, you want to keep the two connected continually. Well, what you're going to do is you'd lease a line from Cox, or you'd lease a fiber line from Time Warner, and you would have direct connectivity continuously between the two buildings, and that's how you create a WAN. Next, I'd like to talk about your backbone in your network. Your backbone in your network is really the connecting cables between floors or between areas in a building. Most of the time when people talk about the backbone, they're going to say, well, did you have a gigabit backbone? You know, they're really wanting to know about how robust your infrastructure is. On my diagram below, to kind of help you have a visual representation of what a backbone is, I've got a 3-floor building. Between each floor is your backbone. That could be fiber, or it could be gigabit Cat5e or gigabit Cat6 connecting into each router. Backbones are very important. You usually don't want to run a weak or a narrow bandwidth backbone, and I'll get into more into that in a minute. Next, I'm going to talk about networking technologies. I really just wanted to bring this up for an education or backdrop information. IEEE, it's the Institute of Electrical and Electronic Engineers. It was established in 1980. This institute is what developed a set of standards called the 802 projects. It's pretty crucial when you start thinking about protocols and how things work together. The 802 projects, you have the 802.3, which was for IBM, and then it rolls on like the 802.11 is what you're going to hear the most of. 802.11 refers to the wireless standards that your laptops or cameras can communicate on. Within the 802.11, there's really 3 commonly used wireless standards or networks. That's 802.11b, G, and N. B came out in the 90s. It was 11 megabits on the 2.4 gigahertz frequency. Everybody was really wowed when we first came out with that. Shortly thereafter, G came out, which allowed you to move up to like 54 megabits on the same 2.4 gigahertz frequencies. And then most here recently, N came out. What's nice about N is it runs on the 5.8 gigahertz, so there's not nearly as much interference, and you have a 300 megabit bandwidth. I recently hooked up a 802.11n router in my house, giving me up to 300 megabits in connectivity, and now my choke point is literally where it hooks into my modem. In my neighborhood, you can only get 26 megabits down. So I've kind of covered topologies and LAN and WANs and backbones. Now I wanted to get into some of the harder aspects of what networks and how the items work together. We're going to start with cable categories. The categories of cable really talk about several things here. You really have like Category 3, Category 5, Category 5E, Category 6 cable. They're all real similar. They all represent data transmission, but the speeds vary between them. Really, when you start talking about twisted pair cable, the tighter the twist, the faster the cable can talk to each other. Below, if you'll see the Category 3 cable, you can see how the pairs are not really twisted together very tightly. And then right above it, you'll see the Category 5 cable, and you'll see that the twists are a lot tighter. Category 5 can move faster speeds than Category 3. To kind of help you understand that, under the category cables and the cable standards is speed length and cable type. So 10 megabit or 10T cable, which is Cat 3, can do 10 megabits per second and can run for 100 meters. 100T cable, which is Category 5 cable, can do 100 megabits, and it's still limited to 100 meters of distance it can run. And then finally, you have your Category 5E or Cat 6 cable, and it is gigabit cable, and it can also still go 100 meters. Everybody wonders why I keep saying the 100 meters part. Well, I really want to emphasize when you're running IP, the maximum distance that you can run it before you have to do an extender or a power injector is 328 feet or 100 meters. Unlike analog cameras where you can do from 100 feet, and if you do an injector, you can do 1,000 feet. The cable standards within the IP world is 328 feet. There's actually several types of category or UTP cable grades. You have Cat 3, which is our 10 megabit that I just spoke about. You have Cat 4. It was really only used during token ring topologies, and it was a 16 megabit. It's kind of fallen out of favor along with Cat 3. And then you have Cat 5, which is 100 megabit, and then you have Cat 5e and Cat 6, which is gigabit. Cat 5e and Cat 6, I often get asked, what's the difference? They're both gigabit. Well, Cat 6 is a thicker copper and has a middle riser to separate the cables as it twists down the main shielded cable, whereas Cat 5e is just tighter wound and then it winds upon itself. Both of them are gigabit. It's up to you on what you want to install. Cat 5e is a little bit cheaper, so most people tend to gravitate towards it. I personally like putting in Cat 5e over Cat 6, not because of the cost, but because I can put the Cat 5e RJ45 connector on 3 times as fast as I can Cat 6. That little riser, for whatever reason, for better or worse, gives me fits when I'm trying to cut it out and move in a fast fashion. Next, I wanted to cover bandwidth and kind of help everybody understand what bandwidth was. Originally, we were talking about backbones and how you wanted to have a robust backbone. Well, that had to do with bandwidth. Bandwidth is really defined as either channel capacity or maximum throughput on your network. When I think of bandwidth, I often give an analogy of imagine going to work from your house. And between your house and your work, you go down this main interstate or thoroughfare. When school's in session and early in the morning, there's a lot of traffic, so you have what I would consider low bandwidth because you're not able to go your maximum speed that you would want to go because there's all the other cars around you. Same thing applies if you had like Cat 3 cable and you only had 10 megabits of bandwidth, but yet you wanted to send 16 megabits worth of data. It takes longer to get that transmitted. However, imagine going to work on a Saturday to pick up your laptop or your wallet that you left at your desk. You leave Saturday or Sunday morning early. There's no traffic. You're able to go to the maximum speed that you want to go and get there twice as fast. Well, that's what happens when you use like gigabit cable or fiber. You open up the bandwidth, and then it's how fast can you transmit that data or how fast can you move it. A while ago when I was talking about cable standards and cable in general, I mentioned RJ45. I wanted to kind of show you a visual representation between an RJ11 standard phone jack connector and an RJ45. That's a common Ethernet cable connector. If you look down below, they're both look like phone jacks. The RJ11 is your standard phone jack that's been around for 100 years. And then the RJ45 is your network connector. It is just an oversized looking phone jack. I just want to give you all a visual representation so you know what one was and when I was talking about it. Along with cable standards, I wanted to address the difference between a patch cable and a crossover cable. So a patch cable is just a shorter cable version of what you're going to run in your network when you're connecting cameras to the switch. Patch cables, if you're wanting to test a camera, require you to plug the patch cable from your laptop into a switch and then get another patch cable and plug it into the device you're wanting to test. That's real important to know. They're set up, the ends are plugged in or wired in just as if you're doing big runs. Crossover cables, however, allow you to test stuff on the fly. Basically, the pins are reversed on each end from each other, and it allows you to plug from a laptop directly into an IP device and get connectivity. The reason why I would suggest you keep a crossover cable in your bag or on your truck is when you're in the field and you're having problems installing something. I mean, everybody's going to know their first couple of jobs. You want to learn from what you're doing, and you may run into a mistake or two. Well, the crossover cable helps you quickly identify what's going on and allows you to log directly into your IP device. It doesn't require you to have a switch or anything like that. It's pretty important that you have these with you for testing purposes, and it'll allow you to then make your install quicker. So we covered what LAN, WANs were. We talked about networks, network standards, along with different types of cable. I wanted to get into some more hardware components and really start talking about network components, hubs, switches, and routers. And I wanted to kind of identify the differences between them. A hub is a device that has multiple ports, which can have several cameras hooked to it or several computers. People often get hubs and switches confused. Hubs are the original switch, so to speak. There's some limitations with hubs. They have no real intelligence on moving data between its two devices quicker. Hubs also share its total network bandwidth. So if you have a 100 megabit hub, then if you have 8 items plugged into that hub, they have a maximum bandwidth of 100 megabits that they can share between them. Next, I'd like to talk about switches. Switches generally have some intelligence built into them. They call them smart switches. It really increases efficiency of data transmissions. What's nice about a switch, and really what separates it from a hub, is a switch is you have a maximum bandwidth per channel. So if you have a gigabit switch, you have a gigabit per channel that you can push data through. This makes it a lot better than a hub. The price between hubs and switches are really not even mentionable anymore, so everybody usually uses a switch or a smart switch. The last is a router. Routers really allow you to speak to different networks in your building or in the world. For example, if you have a network set up at your house, a LAN, and everything on that LAN can talk to each other, but when your LAN or a computer on your LAN wants to talk to the internet, to a computer in a different state or a different country, you have to use your router to transmit that data up and out, and it manages that. Along with talking about network components, I wanted to talk about MAC addresses and what is a MAC address. You'll hear that term thrown around loosely. MAC address, which is a media access control, it really is referred into the physical address that is set up onto each NIC card or on each device. Think of them like Social Security numbers. Nobody has the same Social Security number in America. Same thing goes for MAC addresses. No one has the same MAC address alike on any of their devices. This allows you to locate devices on a network quickly and easily. Now I want to kind of discuss the differences in protocols. There are two basic protocols used in the world today, TCP, IP, and then UDP. I'll start with UDP, and the reason why I'm going to start with UDP is most, or if not all, IP cameras use UDP protocols. For better or worse, they allow you to transmit live data quicker, and I'm going to explain that. So UDP protocols allow you to transmit data packets. What's nice about UDP protocols is they do not require a packet to check and make sure that your other device has received the data. So they can spool out a lot of data real fast, and then they move on to the next task. So if you imagine an IP camera being set up, it's just going to start spooling out data. It doesn't need to check and make sure that you got the data. It's just going to keep feeding it in a live fashion. If you get it, great. If you don't, that's unfortunate. TCP IP, well, that was developed in the 1970s for ARPANET. It was really set up to make stuff scalable and more reliable. What TCP does is it sends out large amounts of data, and then every so often it'll send out a message asking if you've got all the data packets. It then waits for a response from the computer it's sending the information to, and if the computer that's receiving it says, yes, I've got everything, then it's going to continue sending the data until it's done with its task. If the computer on the other end sends back a message saying, I'm missing data packet 3 of 100, then it knows, hey, let me resend data packet 3. It keeps all your programs complete and whole. A lot of people sometimes don't always grasp the difference between TCP versus UDP. So I actually took this straight out of my first networking class that I took. Imagine the post office. You have several different ways of mailing items in the post office, but imagine you can send a letter registered. That's just like TCP. You send it registered, postman delivers it, he requires a signature, he sends that signed piece of paper back to me. That lets me know that my mail made it to the recipient. UDP, on the other hand, is like sending postcards out for Christmas. I'm going to send 100 postcards out to 100 people, and if they get them, they get them. If they don't, they don't. I don't really want to spend too much time thinking about it. It's just about ease of use and getting it out there. IP addresses would be the next thing that we're going to talk about. It's required for TCP IP communication. IP addresses must be unique on each network on a LAN or WAN. You do not want to choose your IP addresses randomly. You usually want to have a method to your madness. If you would think that the 192.168.1.1 is your base IP address on your LAN, then you would want to go up in a systematic order as you add devices to that. I'm going to go into detail in that here in a minute. Other parameters around TCP IP are subnet mask, default gateway, and DNS servers. As we talk about that, I wanted to kind of show you where you would set that up on a computer. On cameras, it's going to be similar. On a computer, if you were to hit your Start button, go into the control panel, and then click Networking. About the 4th or 5th one down on your Windows networking connection properties is something called Internet Protocol version 4, TCP/IPv4. You click the properties on that, and to the right of it is what box would appear. You can see how you have your IP address, your subnet mask, and your default gateway. That's where you set everything up, and each computer and each camera needs to be independent or different from each other. A subnet mask, I often get that question, like, what is a subnet mask and how does it apply to me? Basically, a subnet mask is a 32-bit binary number system. Really what people need to take away from what is a subnet mask is it allows you to know how many routers you need to talk between networks. I'm going to give you some examples. Subnet mask classes, so you have 3 classes of subnet mask. You have a Class A, a Class B, and a Class C. Class C is what 95% of us are going to use, 255.255.255.0. When you set up that subnet mask, that means that on my network, that my computers that can talk to each other are, I'm going to have 256 possible combinations, including my base one. So that means I can put 255 cameras on a network, or I can put 255 devices on a network. Class B allows you to scale up into a larger infrastructure system. It allows you to put 65,000 different IP addresses on one network, and they can intertalk between each other before you would need a router. Class A actually takes it up from there, and that allows you to do up to like 17 million possible combinations before you would need a router. For better or worse, most everybody is going to use Class C. When we start talking about IP addresses and the ranges of addresses that people are going to use, I wanted to kind of talk to that as well. You have Class A, Class B, and Class C. About 95% of y'all are going to use 192.168 dot something for setting up your networks. If you see a 172, that's if there's a secondary network in your LAN, or so you have a couple of LANs in an area or a building. The 10 networks are generally going to be your commercial grade network set up by like a Cisco IT director. So most everybody, you're going to do 192.168. And the next couple of trainings, we're going to dig into that even more to help you understand how to set up stuff on a network. And hopefully that'll answer a lot of your questions moving forward. The next thing I wanted to kind of cover and educate people on was the dynamic host configuration protocol. Everybody doesn't say that. You know, what they say is DHCP. What's nice about a DHCP protocol is it reaches out on a network. You don't have to set anything up. It'll just reach out and ask the router or smart switch, who am I and what IP address can I use? It automatically identifies that based off the information given from the router or smart switch, and then it gets its own IP address. And then it is automatically on the LAN, and you're talking to it. I wanted to talk about ping characteristics. It kind of ties into TCP IP. To ping something is really to test the connectivity between two devices on your LAN. This is real important to know. If you were to go to your start menu and go into the command prompt and type ping plus an IP address, you would see if it is live and it is working. Typically, what you're going to see is if you were to type in ping space and then an IP address like 192.168.2.10, the following information would roll out. What you want to see is that you have 0 data packets lost and that everything was received. So that means you're having connectivity between two devices. If you do not get that, if you get a timed out several times in a row, listed right one after the other, that means that if you're trying to ping a camera to see why the camera's not coming up, that means either the camera's not plugged in, the camera doesn't have the right address, so it may not have the right IP address, it may not have the right subnet, it may not have the right gateway. Or you may have the connectors wrong. I mean, you could have the pin out in your cable wrong. Also, please note, if you're going to be installing gear, I always suggest having a cable tester that allows you to plug into each cable as you terminate it and make sure that the pinout is correct and you're getting connectivity down the cable. Next, we're going to move into DNS characteristics. DNS really defines things in a hierarchical namespace for computer networks. When you think of DNS characteristics, what does that mean to you? Well, in layman's terms, you hear me talking about an IP address, 192.168.whatever.whatever. Well, if you were to call me and say, hey, I want to go to your website, and I said, great. And so instead of directing you to supercircus.com, what if I told you you needed to go to 72.374.whatever.whatever? Numbers are real hard to memorize. For that reason, they really came up with the DNS characteristics, and it allows you to attach names versus numbers to get to an address. Below, you can see my photo representation, like Microsoft.com. Well, really, when you type in a name, it actually points to a numeric IP address and directs the person to that site. Next, I'd like to cover the differences between dynamic IP address versus static IP address. Internet Service Provider, ISP, is what that's called. I can either give you a dynamic IP address or a static IP address. Dynamic IP addresses change. They're dynamic. They do not stay the same. They change based off of the ISP and their protocols. You could have an you could have a dynamic IP address that changes every 5 minutes, or it could change every 5 days. We really don't know. Static IP addresses are different. They never change, and they're something that you have to get assigned to you from your ISP, and they generally make you pay for it. If you're lucky, they will not, but 9 out of 10 ISP providers charge you $10 to $50 a month, usually towards the higher side. They usually tell you they have to get a commercial cable connection to get a static IP address. How to manage dynamic IP addresses without paying for a static is pretty simple to explain here. One of the hardest things that you're going to explain to your customer, however, is after you sell them the gear, after you charge them for the labor for the install, you're now going to make them pay to their ISP provider a static IP address. Again, this varies from, really $10, $30, $50 a month. It generally dances between the $30 and $50 range. One of the benefits we can help you with this heartburn is really a DNS server. It's something we provide to our dealers at no additional charge. A DNS server, for your understanding, allows you to set up a name IP address, and then it keeps up with the numeric IP address as it changes. So imagine you set up bobshomedvr.com. Well, our DNS server, or any DNS server, says, okay, bobshomedvr.com has this numeric IP address. And then it's going to check, and then anytime that changes, it's going to update it. So when you come in and you type in www.bobshomedvr.com, it goes to the DNS server and says, hey, what's my current numeric IP address? The DNS server responds with, here's your proper address, and it directs you to the site. We provide this server, this cost for free. There are several online sites. They generally charge around $39 a year. It's still cheaper than doing the monthly deal from your ISP provider. What I know most of my dealers are doing now is, since they are managing or charging to watch their burglar system, $14.99 to $24.99 a month, what they'll do is they'll also add, for RMR, they'll add a $5 upcharge to do their DNS server. They explain what they're going to do for them. We actually do not charge anything to our dealers for this service, and then they get to charge RMR. They manage it on their end. We actually teach the dealer how to log on, how to set everything up, how to manage it. It's pretty simple. Next training will actually cover that in detail. I wanted to kind of close on terms applied to our industry, just to kind of help wrap things up. I mean, we've covered infrastructure, setups, LANs, WANs, and then we covered components such as Cat5 cable and hardware such as switches and hubs. And then we rolled into, IP addresses and MAC addresses. Last, we're going to talk about terms and gear-based information in our industry. Pixels versus megapixels. Pixels is really used as a unit of measure. It's really, in our industry, it talks about a measure of resolution, such as 2,400 pixels per square inch. Mega refers to 1 million. Therefore, if you have a 2 megapixel camera, you really have a 2 million pixel camera, or right at a 1080p camera. DVR versus NVR. In the analog world, DVRs have been around for almost a decade. DVRs are a digital video recorder. DVR takes analog cameras, converts it over to a digital signal, and records it to a hard drive. Most DVRs are networkable, and people then get that confused with an NVR. NVRs do not take in analog signals. They are going to take in IP signals from the beginning. So you can take an IP signal in, it records it to the hard drive. It is also networkable and can be viewed anywhere in the world. What separates most DVRs to NVRs is IP cameras. IP cameras, the lowest resolution of an IP camera is the highest resolution of a DVR. So your NVR is going to be able to record standard analog D1, which is a low resolution for IP cameras, all the way up to 5 megapixel or 10 megapixel. NVRs is kind of where everybody's moving towards. It allows you to have the CSI moments where you can zoom in after the fact from recorded video and get that facial shot, or the guy breaking into the house and stuff like that. Well, that kind of concludes everything that I wanted to talk about today. Please let me know any questions, and we will go from there.